Good morning, students. For today's class, you're going to need pencil, paper for notes. We're actually going to get started on talking about what's linear combination or a system of equations through elimination. So before we talked about systems doing through substitution. So that means in order for us to find that point of intersection, we had to substitute information in for a variable in order to solve for one, and then substitute that answer back into one of the original equations. So the title for the notes today is linear combination. Notice the little combo, putting something in, getting some mixture. Or it's also called system of equations through elimination. So we need to take something out in order to solve for the other variable, hence the little trash bags. So make sure you write down these steps. These steps are going to be vital in order to understand the process of elimination. So first things first, always make sure that your x's and your y's are lined up vertically. Notice the green line. So vertical is up and down, horizontal is left to right. So once you notice that your x and y's are lined up vertically, follow this pattern. Same number, same signs, subtract. So when you have the same number, I'm talking about the coefficients in front of the variable. So if those numbers are the same, then you're going to take it a step further. Look at their signs. Is that number positive and the other number's positive? If so, you're going to subtract your two equations, just like you did back in elementary school. And I'm going to show you some examples shortly. The next thing is same number, different signs, you're going to add. So if they're the same number, but one is positive and one is negative, you're actually going to add those two equations, just like back in the day. So once you figure out when you're adding or subtracting, go ahead and do that. Then you're going to get an answer for either one of the variables. You're going to take that variable, which goes to bullet number 3, and you're going to substitute your answer into one of the original equations, okay, in order to find your point of intersection. So first thing, are your x and y's lined up vertically? So are they lined up in the column? Then you look to see if you have same numbers. Are my x's the ones that have same numbers? Or are my y's the ones that have same numbers? Those are the only type of numbers that you're looking for, okay? Because we're trying to find our variables. If they're the same number, are they the same sign? If they're the same sign, you're subtracting. If they're different signs, one's positive, one's negative, you're going to add. And then we're going to take our answer and we're going to substitute it into one of the original equations. So for example number 1, we have 3x plus 5y equals negative 7. Negative 3x minus 2y equals negative 1. So the first thing I should be thinking of, are my x and y's lined up vertically? So if I were to put ovals around my x and y's, are they lined up? In this case, they are. So up and down, I definitely got my verticals for my y's and for my x's. So now the next thing I should be thinking of, come with me. Do you have the same number? So that's the first thing. Which one of those two variables have the same number? Is it my x's or is it my y's? So hopefully you guys said my x's, okay? Both of those x's have a 3 as a coefficient, okay? So since they have the same number, what about their signs? We're not looking at the operation. We're not looking at the plus 5y or the minus 2y. We're just really focusing our attention on the sign that's before the number. So at the top equation, the sign is a positive 3x. On the bottom equation, the sign is a negative 3x. So are they the same sign or are they the opposite sign? So hopefully you're saying they're opposite signs. So if they're opposite signs, we're doing what? Let's go back to the rules. So same number, same signs, subtract. Same number, different signs, we are adding. Good. So if we're adding, I would like for you to put a plus sign and put a circle around that plus sign. So when you put a circle around that plus sign, it's acting as a reminder that you are adding. And when you're adding to cancel out in my situation, right now we're going to eliminate our x's because 3 plus a negative 3 is 0. So right there, we just eliminated our x's. So in order for me to eliminate those x's, I had to add. But guess what? I still have to add my y's and I have to add my constants, which are the numbers -7 and -1. So now this is how we're going to do it. 5y plus a -2y will give me 3y. The reason why it's a -2y right here is because that minus sign is associated with the 2, because that minus sign is in front of that 2, okay? Because we're subtracting 2 of the y's from that equation. So now we have a -7 plus a -1, which gives me a -8. And you're probably saying to yourself, oh wait, well, 3 divided by, that's not going to give me a whole number. Guess what? In math, you're not always going to get whole numbers. So you get over it, okay? So now, I'm solving for y. That means I need to divide both sides by 3. So right here, y is going to equal a negative what? I think it's like around 2.7 if I'm not mistaken, if it's rounded. So we found what y is. So now it comes to my next step. Step 3, did you solve for both variables? Ooh, did I? No, I didn't. I just solved for one of them. So I need to plug that -2.7 in for one of my, for the y, for one of my equations. So let's take a look. If I take that 2.7, I can pick any one of those two equations. It does not matter. So let's say I want to pick the first one. I don't know, just because. So the first equation is 3x plus 5y. But instead of a y, I'm going to put that, oops, oh, it froze up on me. Okay, so I'm going to put that -2x in for that y. I love when it freezes up on me. It's so much fun. All right, let's see. Oh, all kinds of funky. There we go. I don't know why that black doesn't want to get rid of, but you know, whatever. It is what it is. Things happen. So anyway, so we have 3x plus 5 times y, but we're going to replace that y with that -2.7 equals -7. So now we're just going to go ahead and solve in order for me to get my solution. Oh, funky. Okay. Don't ask me where these lines came from. I don't even know. So weird. Welcome to my world. All right, so now we have 5 times a -2.7. So that will give me a -12.3. Let's see if it's writing. All right. Sorry, I'm trying to do stuff behind the scenes here because I didn't want anything weird to happen again. All right. So we have a negative 13.5. So now from here, let me raise this up a little bit. So we have 3x minus 13.5 equals negative 7. I'm solving this for x. So that means I need to add 13.5 on both sides. Okay. The reason why I'm adding it is what? It's because originally I have a negative 13.5. So now I have to do the opposite so I can get my numbers on one side and my variables on the other. So here I have a 3x equals 6.5. Where's my point? There it is. And then I'm dividing both sides by 3. So if I have 6.5 divided by 3, what's my lovely answer? I think it's 2.1, and it's a whole bunch of sixes, so let's round it. Let's say either 2.17, or we could say 2.2. Round it. Okay, since we round the other one to the 10th position, I might as well round this other to the 10th position. So now, that final question, which I have here for step 4, what is my solution? So anytime I'm asking for a solution, I want the order pair. So remember, order pair is your x value, then your y value. So my x, we said, was 2.2, and my y was a negative 2.7. So this is the point of intersection. If I were to graph these two equations right here, once I put them into slope-intercept form, I know that they're going to intersect at point 2.2 and negative 2.7. Okay? I know you saw decimals and you're like, it's got to be wrong. No, because decimals are numbers too. So for example 2, you have 7x plus 4y equals 2. 7x plus 2y equals 8. So now, first things first, are my x and my y's lined up vertically? So let's take a look at my x's. Okay. Let's take a look at my y's. Are they lined up vertically? Yes, they are. So my next question, do we have same numbers? Do we have same numbers for the y's since I'm here? No, I don't. How about for my x's? Yes, I do. They're both 7s. Now look at their signs. Are they positive 7s or negative 7s? They're both positive 7s. So, same number, same sign, we are subtracting. So think about it, SSS, same number, same sign, subtracting. So when I subtract 7 minus 7, they cancel out, give me 0. Now I go 4 minus 2, which gives me a 2y, and 2 minus 8, which gives me a negative 6. So if 2y equals negative 6, that means y equals negative 3. And the reason why y equals negative 3 is because I had to divide, I'll write it small, both sides by a positive 2. So we found y. Now we need to find x. So we're going to take this negative 3 right here, and we're going to substitute it in for y in one of the two equations. So let's just pick. Let's pick the second one. So you have 7x plus 2, and instead of the y, that negative 3 is going to go there, and that equals 8. So let's go ahead and solve. So order of operations. Please excuse my dear Aunt Sally. So that means I have to do multiplication first. I have parentheses, but this parentheses, there's nothing in there except for a negative 3. I don't have exponents, so the next thing I should be doing is multiplication. So 2 times negative 3 gives me a negative 6. Bring down the 7x and the equals 8. So I need to solve for x. So this x right here is not going anywhere right now. That means I have to add 6 on both sides. So these 6's can cancel out, leaving me with 7x equals 14. So if 7x equals 14, that means x equals 2. So my ordered pair, or my solution in this case, is 2, -3. Okay? Remember, it's your x before your y's. Even though our first answer was a -3, that -3 was associated with y, not with x. Okay? And also be cautious where you're substituting your answers to. So the next one, we have 2y plus x equals 6. 3x minus 2y equals 2. So first things first, are my x and y's lined up? If I look here, no, they're not. My y's are over there, my x is over here. If I look over here, my x is on top and my y is on the bottom. So we're going to need to do something before we can get any further. We're going to need to rearrange either the top equation or the bottom equation. So it's up to you. If I want to rearrange this top equation, that means I can just simply flip the x and the y's around. They're both on the same side of the equal sign, so I don't have to do any subtraction. All I have to do is just flip things around. And I'm cheating a little bit because I'm cloning things. And all I did underneath what was written in blue is just basically rewrote, or again I cheated and cloned, the bottom equation. So now I should have my x's lined up and my y's lined up. Okay, so now everything's right in the world. So now that we have them lined up, do we have any same number? Hopefully you said the y's all have 2's, but are they the same signs? Let me draw it in a little bit so you can really see it. So they're the same numbers, but are they the same signs? No, they're not. One's positive and one's negative. So since one's positive and one's negative, that means we're doing addition. And I put a little addition symbol and I circle it just to remind myself that I'm adding everything. I'm adding the top equation with the bottom equation. So now I have x plus 3x. That's going to give me 4x. The reason why, there's a 1 to be assumed in front of that x. My y's are going to be eliminated. And now I have 6 plus 2, which gives me 8. So if 4x equals 8, that means x equals 2. So now we're going to take this 2 and we're going to substitute it back into one of the two equations, n for x. Okay? We can go with the top equation, we can go with the bottom equation. Actually, I'll go with the top equation this time, since we did the bottom equation last time. Let's continue the loop. So now I have 2y plus, which I'm going to put my 2, equals 6. And if 2y plus 2 equals 6, that means I'm solving for y. So exchange, I have to subtract 2 on both sides. So these 2's can cancel out. Now I have 2y on one side equal sign and 4. So if 2y equals 4, that means y equals 2. So my solution is 2, 2. So 2, 2 represents the point of intersection. Example 4, I took a moment and just had the students try to work out their plan. So I was just curious to see how they were going to approach this. So as you can tell, if I look at my x's and I look at my y's, they are completely lined up. But what do you notice about the x's and y's? Hopefully, you notice that with the x's, they do have the same number, but they have the same sign. So since I have same number, same sign, I should subtract. But I look at my y's. They also have the same number, but they have different signs. One's positive and one's negative. So since they're the same number, different signs, I would have to add. The whole purpose of this was for me to see which way they would eliminate. Either way should give me the same answer. So let me cheat and clone. Okay? And what I'm planning on doing is showing you that you should get the same answer regardless of how you set it up. So let's work to the left, let's work to the right. Stand up, sit down, fight, fight, fight. Sorry. So one way is going to be shown on one side. Another way is going to be shown on the other side. So let's work on the left side. So let's say on the left side, I want to, let's say, eliminate my x's. And on the right side, let's say I want to eliminate my y's first. So if I want to eliminate my x's, I'm looking at my x's. They're all vertically lined up. They both have the same number, which is 1. They both have the same sign, which is positive. That means I'm subtracting. Same number, same sign, subtract. So if I'm subtracting, that eliminates my x's. But I have a 1y minus a negative 1y. When you minus a negative, it's the same as saying a negative multiplied by a negative, because that's what's happening. So when you say a negative times a negative, it'll give you a positive. So as an end result, you should have 2y. They're not going to cancel out. If you put in your calculator 1 minus a negative 1, it will show up an answer of 2. Because when you minus a negative, it turns into a positive. So that's going to equal negative 4 minus 2, which gives you a negative 6. Your eyes are going to try to fool you. You're going to look at that negative 4 and you're going to look at that 2 and you're automatically going to write negative 2. I know it for a fact, okay? But don't forget to use this symbol. Have the symbol, put a circle around it to use as a reminder. So if 2y equals negative 6, that means y equals a negative 3. So we're going to take that negative 3 and we're going to substitute it in for one of our equations. I guess I'll use, I reckon I used the first one. So it doesn't matter. You're going to get the same answer, so don't freak out. So now I have a negative 3. I have a plus negative. A plus negative is just simply saying x minus 3. Okay? So it's almost the same as saying a positive times a negative. That's going to be a negative. So since I want to get x by itself, I need to add 3 on both sides, which means that x is going to equal negative 1. So in this case, my ordered pair is a negative 1, negative 3. So now let's take a look. On the other side, We want to solve this by eliminating our y's. Remember where I wrote that? So if I want to eliminate my y's, I need to look at my y's. So my y's, I have a positive y, I have a negative y. Same number, different signs. That means I'm adding. So when I add, I have 1x plus 1x, which gives me 2x. 2x equals what? Negative 2. Because it's a negative 4 plus 2. Therefore, if 2x equals negative 2, x has to equal negative 1. Wait. So I'm going to take that negative 1 and plug it in for one of my equations. I'll use the bottom one. So I have my negative 1 that's going in for the second equation. Okay, minus y equals 2. So I want to get y by itself. That means I have to add 1 on both sides. Then I have a negative y equals 3. We are not done. I want to know what y equals. So if negative y equals 3, that means y is going to equal a negative 3. Because if I divide everything by negative 1, my negatives are going to cancel out, leaving me with my y. 3 divided by negative 1 is just negative 3. What do you notice? Because my point of intersection is negative 1, comma, negative 3. What do you notice? Come on, share. They're not perfectly lined up, but you get the same answer. So in this case, it all depended on what you wanted to eliminate. When it comes to system of equations, when it comes to solving, you have to make decisions. So sometimes you don't like to make decisions, but guess what? Suck it up. You're going to have to make decisions. Okay? You can definitely get this done. Don't be afraid to make a choice. If you make a choice and you work it out, if you take your answers and plug it back into the original and it doesn't work out, just try again. Please, it's not life or death. Okay? So in this case, it didn't matter which way you did it, you got the same answer. All right, 2 more examples. I know it's been forever, right? So what do we notice this time? So we have 2x plus 5y equals 3. Negative x plus 3y equals negative 7. So if I put my magic circle around it, I notice that my x's are lined up, and I notice that my y's are lined up. But what else do you notice? Do we have the same number? No, we do not. So what are we going to do? I need the same number in order for me to do elimination. Besides lining up my x's and y's, that is key when it comes to elimination. I can't just simply add, because if I just said I wanted to add, if I add this, I'm going to have x plus 8y equals a negative 4. How is this going to help me to find just this equation right here? How is that going to help me find my point of intersection? How am I going to go from this equation to an ordered pair? Can I do it without doing anything else, just looking at the equation? I can't. So it is not a no solution. Don't be so jumpy with those things. There is a solution. Come on, darling. Okay. It just doesn't feel like it today. So there is a solution. The way that you're going to solve this is through multiplication. So we can do some manipulating in order for us to get same numbers. So let's take a look. If I look at my x's, looking at the numbers alone, I have a 2 and I have a -1. What number besides 1 do they have in common? Both of them, if I multiply them, I should get 2. Now, would it be easy for me to change that 2 into a 2? I don't really have to do anything. But I can change that -x into a -2x just by multiplying it by 2, right? So that if I multiply that term by 2, I would get same numbers. Beautiful. Let's take a look at the y selection. What number does 5 and 3 have in common? It's not 3. It's not 5. It's not 10. 10 can't go into 13 and 3. It's 15. Because if I multiply 5 and 3, don't I get 15? So in order for us to get same numbers, I have to change that 5y into a 15, and I would have to change that 3y into a 15. In order for me to change the 5y into 15, I have to multiply it by 3. In order for me to change that 3y into a 15, I got to multiply that equation by 5. So I got to multiply the top equation and the bottom. Whereas with my x's, I just have to multiply just the bottom one by 2. So it's how you want to approach things. It all depends on what equation you want, or what equation, not equation, what variable you want to cancel out. So let's say I want to cancel out my x's. I want to eliminate my x's. So that means I need to multiply that first term by 2. But just like in math, you can't just multiply just the one term. You got to multiply the whole equation, even after the equal sign. You got to multiply that -7 as well by 2. So remember, it's just like distributing. So I'm multiplying everything by 2. So when I do that, I'm going to write it off to the side. I got a -2x plus 6y equals a -14. Just to keep things up in columns, I'm going to take that top equation, and I'm lazy, I'm going to clone it. I'm not going to lie. Okay? I'm going to clone or rewrite that first equation and put it underneath it. Okay? It could be underneath it. If you wanted to put it on top, you can do it on top. Okay? Either way, you're going to get the same answer. But make sure that your x's are lined up and your y's are lined up. Okay? Let's put it on top just so it can be consistent. So now, looking at my numbers, okay? Now my x's, I have the same number, but I have opposite signs. So then I'm doing what? I'm adding. Remember, same numbers, different signs, addition. Same number, same sign, subtraction. So when I add, my x's cancel out. So now I have 5 plus 6y gives me 11y equals 3 plus -14 will give me a -11. So if 11y equals -11, that means y equals -1. So I'm going to take that -1. I'm going to substitute it in for one of my y's. I'll use the first equation. So we have 2x plus 5 times my -1 equals 3. 5 times -1 gives me a -5 equals 3. Bring down my 2x, add 5. So I have 2x equals 8, therefore x equals 4. So my point of intersection for this case is 4, comma, negative 1. Okay? So the most difficult part of this is to know your multiplication table. Your x's and your y's have to be lined up. Then after you line up your x and y's, take a look at the numbers. What number will go into the 2 and the 1? What number will go into the 5 and 3? Well, if I did 5 and 3, yes, I'll have to multiply that whole top equation by 3 and that whole bottom equation by 5 so I can get my same number, 15. But your answer will be a positive 4 for the x and a negative 1 for the y. Okay, let's try this last example. So, first things first. Take a look at your x's, take a look at your y's. Are they lined up? Okay, my x's are lined up, my y's are lined up. Or do they have the same number? No, they do not. So now, what do you want to eliminate? Do you want to eliminate your x's or do you want to eliminate your y's? The choice is going to be yours when it comes to the multiplication. So if I wanted to, I could eliminate my x's, but I have to think of what number they both have that I can, the lowest number that they both have other than 1, that will help me with the whole same number type of pattern. So for the x's, I would have to multiply the top equation by 3 and the bottom equation by 5. If I look at my y's, I notice I would have a 2 and a 6, a negative 2 and a positive 6. But let's hold off on the signs real quick. I have 2 and I have a 6. What number other than 1 do they have in common? So hopefully you say 6. So if that's the case, I would only have to multiply that top equation by 3. So since we kind of took it easy the last time, oops, forgot to do that. Let's see if we can, come on, baby. Okay, let's see if we can do the multiplication this time and try to eliminate our x's. So if I wanted to eliminate my x's, I need to multiply this top equation by 3. And I need to multiply that bottom equation, I'll use a different color, by 5. So when we do the multiplication, you have to multiply 3 to everything. Cannot emphasize that enough. So 3 times 5x gives me 15x minus 6y equals a negative 30. The bottom equation will also give me 15x plus 30y, whoop, that's ugly, equals 3,330. You can tell it's getting to the end of the day. So now, since we did that multiplication, looking at my x's, I have 15x and 15x. Do they both have the same sign? Yes. So we have same number, same sign. We should be subtracting. So I write my subtraction sign, put a circle around it as a reminder. So right away, my 15x's are canceling out. So I have a negative 6 minus 30. So negative 6y minus 30y gives me a negative 36y equals a negative 30 minus 330. I know you're freaking out. You're like, oh, what is that number? So it's negative 360. Okay. Divide both sides by negative 36. So that means y equals a positive 10. So if y equals 10, then we have to plug it in. Now, you want to plug it in. I know I just freaked you out for a second. Sorry. You want to plug it in back to one of the original equations. The reason being, just in case this never happens. Okay, I'm lying. It does. Just in case, let's say the top equation, you multiply it by 3. You did your 3 times 5x, you got your 15x. You did your 3 times negative 2y, you got negative 6y. Equals negative 10. It happens. Make sure you do the distribution to everything, but there's going to be times you're going to forget to distribute to what's after the equal signs. So you have to do that after the equal signs. So if you don't do it, and you plug your answer back into one of the equations you just did the multiplication in, guess what's going to happen? You're going to get it wrong, okay? Even though that first process is wrong, yeah, it'll screw up your answers for the other process. But I know in the beginning, hopefully, I'm just looking at your process, and we're going to get to the math, but I really want you to emphasize both of it. But I would like for you to plug it back into one of the original equations. One, the numbers are not as large, right? Because you're multiplying. If you're multiplying, you're making it bigger. So obviously you're making the numbers larger, okay? So plug it back into one of the original equations. Let's use the second one. So you have 3x plus 6, and we're going to plug in that positive 10 equals 66. So we have 3x plus 60 equals 66. That means 3x is going to equal a positive 6 because you subtract 60 on both sides. So therefore, x equals 2. So my point of intersection is at 2, 10. All right. So 6 examples. So I want to hear, I don't know what I'm doing. Look at the examples. Quit your crying. All right. So you have 6 examples. 4 of them dealt with just simply looking at same number, same signs, or same number, different signs. And 2 of them dealt with the multiplication. So if you look and you do not have same number, that means you need to do some multiplication to create same number. It depends if you want to get rid of your x's or you want to get rid of your y's. I know this last example was a bit much because it was larger numbers. And yes, we could have just simply multiplied that top equation by 3. Okay, so we won't have to deal with larger numbers, but it all depends on what you want to eliminate. And I just felt like eliminating my x's first. So there, okay? So as a result, I gave you a homework assignment. It was a total of 5 questions, okay? A couple of them had to deal with solving with just the same number, different signs or same signs. And you also had some that you had to do the multiplication. So this was the first homework assignment, okay, after the notes for 3rd quarter, 2nd semester. Complete that, okay, it's also on the website under the attachments. Just download that and turn that in if you have been absent for the duration of 2nd quarter. But my suggestion for this semester, do not wait to turn information in. I want you to learn this stuff, not just simply, oh, I need a grade, because your grade should reflect your knowledge. And if your knowledge is poor, your grade's going to be poor. So again, if you need assistance, myself and Ms. Cavanaugh are available. First lunch on Tuesday, Wednesday, Thursday in room C107. Ms. Cavanaugh will be in room C107 on Friday, and I will be in the Media Center on Friday, first lunch during Wildcat Hour. I do not have anything second lunch because that's my lunch and I would like to eat. Thank you. All right, so if you have any questions, if you have Cap North and you just want to ask a quick question, come down during CATS. I will actually get in touch with your CATS teacher. Once you come down, then make sure you come down on time. All right, well, good luck with your homework, and I'll